Hi there and welcome. My name is Matthew. I'm with Perspic, and today we're going to go over and review the basics of our CAN-Isolator 2500 product. This device isolates and separates the grounds, or galvanically isolates two different CAN segments of the same network. So here is our setup for today. We have two CAN to USB devices here, which we're going to use to send data on each of these segments of the bus. We have a CAN 1 side and a CAN 2 side. Each side we've got broken out into CAN high and low, CAN high and low, and then we also have a power and a ground, and a power and a ground on each side. In this first demonstration, we have 12 volt power coming into the CAN isolator device through these leads here, connected to a power supply on the bench. So the goal of the CAN isolator is to allow CAN data to pass through the device, but not allow transients on the ground or power lines to pass through the device. So here we're going to demonstrate if we apply a voltage to the CAN lines while passing data through the device, that voltage will not affect devices on the other side of the network. We also have a oscilloscope leads on CAN 2 high and low and CAN 1 low and high. That's just going to allow us to graph the data and see what the waveforms look like, both going into and coming out of the device. So a little bit about our CAN isolator. It is a transparent device where CAN signals can pass through very quickly and very easily. The advantage of this is you can pass CAN signals between two different devices that are on the same network but powered by different power supplies. So this is important in like battery electric vehicle applications, sensitive measurement applications, and things like that. We test this device at anywhere between 5 kilobits per second to 1 megabit per second. One of the advantages of our product is that you don't need to set that. So because it's a more passive CAN device, it just passes the data through. The device will work at any of those data rates without needing to configure it. For the first demonstration, we're going to pass some data from CAN 1 to CAN 2 and see what it looks like on the oscilloscope. So let's jump over to the computer. Okay, so here we are on the PC. We've got two CAN Analyzer 3 mini windows up here. Each of these is mapped to one of the USB to CAN devices shown in the last clip there. And so we'll start sending some data here. We're going to send a CAN message with hex ID 234 at a time of 100 milliseconds. That means 10 messages per second. So here we go. So you can see here the message is being transmitted 10 per second on the first CAN interface, and it's being received here 10 messages per second on the second CAN interface. So we're going to go ahead and jump into our oscilloscope, and we'll see what these messages look like in the oscilloscope. So here you can see CAN 1 is in blue and CAN 2 is in red. You can see them kind of waving around. That's every single message that goes through gets updated on the waveform there. So if we zoom in here, we'll be able to see the CAN bus delay. So here we can see the red waveform is the one where the USB device transmits, and the blue waveform is the one where the CAN isolator transmits. So here you can see a zoomed in view of the transmitted and received CAN waveforms. The delay between the CAN isolator receiving a rising or falling edge and transmitting it onto the next bus is 150 nanoseconds. Because of this delay, the maximum recommended length of the CAN bus is shorter when using the CAN isolator, and it depends on the system bitrate. Check out this table that's also in our user manual for recommended maximum bus lengths depending on your application's bitrate. So you can see here the CAN isolator is working properly. We have data on one side getting to the other side. In the next demonstration, we're going to do a similar thing, but we're going to actually apply a voltage between the CAN 1 and CAN 2 side of the isolator, and we'll see how it performs. All right, so here's our setup for the high voltage test. In this case, we still have the same CAN isolator in the middle. We have CAN 2, or the system side, is being powered at 12 volts to the power side. We have a high voltage power supply, high voltage DC power supply connected between CAN 2 low and CAN 1 low. So those wires go out to a 120 volt power supply. And then also connected to that, we have the multimeter, and this is going to read out the voltage that we're applying between CAN low and CAN low. Because we're going to apply voltage to the two CAN sides, we obviously need a isolated power supply. So in this case, we're just using a 12-volt battery connected to this device. Takes any CAN message it receives, it transmits it back within about 10 milliseconds on the same CAN bus. So if the system works as intended, we should measure up to 120 volts on here as we crank up the voltage. And then also as we crank up the voltage, we will see the CAN messages both going out from the USB to CAN device, and then we'll also see CAN messages coming back in at the exact same time. Okay, here we are back in our CAN analyzer software. We have it set up with the same message, hex ID 234, being sent out every 1,000 milliseconds. So every second we send out a new message, and you can see those messages going through here. And back on the bench, we're going to go ahead and start cranking up the voltage. So we'll go ahead, and those messages are still going through. There's 10 volts. 20 volts, 30 volts, 40 volts, 43, 50, 60, 70, 80, 90, 100, and we should be able to get it up to 125. 121. There we go. So now we're seeing every flash of the CAN message here. Every green light is a message that goes through, gets sent and received. And we have 120 volts of voltage being applied between CAN 2 low and CAN 1 low. So our CAN isolator is doing its job. It's not letting that 120 volts create any current across the isolator, but it is letting that data go through and then get returned back to our device. One of the big applications for this sort of a setup is where you have a high voltage motor controller. So say 96 volts or something like that, big, heavy, thick gauge wire, and that needs to be isolated with a device that needs to be separate from your control side. So this could be PLCs, HMIs, that sort of stuff on this side of the network, which are all going to be powered at between 5 and 24 to 28 volts DC. And then you have sort of a high voltage or high power side of the network where you might have motor controllers, motor drives, VHDs, that sort of stuff, where you need some isolation there because there's two different powering the different devices on the network. If you have a battery electric EV kind of application, or any application where you have a main network supplied with anywhere between 5 and 12 volts DC, and you have a secondary segment of the network that you want to be seeing the exact same CAN messages, our CAN bus isolator will help you do that. And in this demonstration, we went up to 120 volts DC, but this device is rated for up to 2,500 volts, AC, DC, or transients. It'll stop them all. Anyway, thanks for watching. And if you have any questions, reach out. Our website is perspic.ca. You can order these products online, and if you have any specific requirements, special projects, get in touch with us.